You're about to witness the entire journey of space exploration unfold. Every era, every leap, every unforgettable mission. You've just clicked the video that takes you through the greatest story ever launched. One spark from a backyard rocket changed the destiny of our species. What followed was a cascade of breakthroughs, secrets, and silent struggles orbiting just above us. You'll uncover how wars gave rise to rockets, how animals paved the path to human flight, how telescopes reshaped our place in the cosmos, and how private companies are now steering us toward Mars. These are the moments that reshaped our future, each one waiting inside. The journey into space began long before rockets ever left the ground. In 1926, American physicist Robert Goddard launched the first liquid-fueled rocket, laying the foundation for future space travel. His ideas were ahead of their time, introducing multi-stage propulsion and guidance systems that would later define space missions. By 1944, during World War II, Germany's V-2 rocket, built under Wernher von Braun, became the first man-made object to cross the 100-kilometer boundary of space. Although created as a weapon, this technology represented a critical step in space access. These pioneering efforts were the seeds of a growing vision, to go beyond Earth, to explore the skies not just with telescopes but with machines capable of leaving the planet. The scientific community began shifting its focus towards space, and interest in spaceflight sparked imaginations globally. Though modest in reach, these early innovations proved that leaving Earth's atmosphere was not just possible, but achievable. Goddard's theoretical designs and Germany's practical breakthroughs formed a dual legacy that both superpowers would build upon in the decades to come. The foundations of space exploration were no longer abstract theories. They had become real, mechanical, and ready to be pushed further into the unknown. World War II played a surprising role in advancing rocket technology. Germany's development of the V-2 rocket under Wernher von Braun not only demonstrated the destructive power of long-range missiles, but also revealed, the potential to reach space. The V-2's ability to climb above the atmosphere really captured the interest of both the United States and the Soviet Union. After the war, Operation Paperclip allowed the United States to recruit von Braun and his team, bringing their expertise into American rocketry programs. This move set the stage for Cold War competition and the birth of national space agencies. Meanwhile, the Soviet Union also acquired German rocket engineers and developed its own programs in parallel. The rivalry between the two powers ignited a race that would extend beyond the battlefield and into the cosmos. Military investments were increasingly funneled into peacetime space research. Rockets, originally designed for war, became instruments of scientific inquiry and technological pride. The transformation of wartime inventions into tools of peaceful exploration marked a turning point. Space was no longer just an abstract concept or military curiosity. It became a frontier both nations were determined to conquer, setting the stage for the dramatic space race that would follow in the 1950s and 60s. By the late 1940s, both superpowers were conducting biological experiments in space. In 1949, the United States launched a rhesus monkey named Albert into space aboard a V-2 rocket. Although he died during re-entry, the mission provided early insights into the impact of space travel on living beings. In 1951, the Soviet Union sent dogs Desik and Sigan into suborbital flight and successfully recovered them, marking the first safe return of animals from space. These early missions paved the way for more advanced biological studies and demonstrated that life could survive space conditions, at least temporarily. The true breakthrough came in 1957 when the USSR launched Sputnik 1, the world's first artificial satellite. This polished metal sphere weighed about 83 kilograms and transmitted simple radio signals. It orbited Earth for 3 weeks and shocked the world, triggering fear and fascination. The success of Sputnik led directly to the establishment of NASA in the United States just a year later. That same year, the USSR launched Sputnik 2, carrying Laika, a stray dog from Moscow streets. She became the first animal to orbit Earth but died from overheating. Although Laika's death stirred ethical debate, her mission provided crucial data on the effects of zero gravity and confinement. In response, the United States launched Explorer 1 in January 1958. It carried scientific instruments that discovered the Van Allen radiation belts, proving that satellites could offer valuable scientific data. These years were filled with firsts that laid the technological and political groundwork for human spaceflight. They transformed space from a theoretical concept into a battleground of prestige and innovation. Each mission added new layers to our understanding of the environment beyond Earth and set the stage for sending humans into orbit. The 1940s and 50s were not just about launching objects into space. They were about redefining what was possible for humanity. When Yuri Gagarin blasted into orbit aboard Vostok 1 on April 12, 1961, the world entered a new era. He was the first human in space and the first to orbit Earth, spending 108 minutes in microgravity. Gagarin's flight stunned the global community and elevated the Soviet space program to iconic status. It proved that humans could survive launch, orbit, and return. That same year, Alan Shepard became the first American in space with a suborbital flight aboard Freedom 7. Though his mission was shorter than Gagarin's, it showed the United States was ready to compete. In 1962, John Glenn became the first American to orbit Earth, further narrowing the gap. The Soviets continued their lead when Valentina Tereshkova became the first woman in space in 1963. She orbited Earth 48 times aboard Vostok 6, proving that women could endure the rigors of space just as well as men. Meanwhile, space agencies around the world were learning how to improve spacecraft stability, life support, and navigation. In 1966, the Soviet Lunar 10 mission became the first spacecraft to orbit the Moon. This success marked the expansion of human reach beyond Earth's orbit. In 1968, NASA launched Apollo 8, the first crewed spacecraft to leave low Earth orbit and travel to the Moon. Astronauts Frank Borman, James Lovell, and William Anders became the first humans to orbit another celestial body. Their mission provided stunning images of Earthrise over the lunar horizon, forever changing humanity's perspective of our planet. The following year, the United States achieved what many thought impossible. On July 20, 1969, Apollo 11 astronauts Neil Armstrong and Buzz Aldrin became the first humans to walk on the Moon, while Michael Collins orbited above. Armstrong's words, "That's one small step for man, one giant leap for mankind," echoed across history. The mission lasted over 21 hours on the lunar surface and brought back rock samples that scientists still study today. This decade of rapid progress transformed space from a dream into reality. It showed that nations could reach beyond their borders and touch the stars. The 1960s redefined humanity's place in the cosmos and proved that space was no longer just for machines. It belonged to people. As humans were preparing for the Moon, robots were being sent to explore the rest of the solar system. The Soviet lunar program sent multiple spacecraft to study the Moon's surface and, some even returned samples. NASA's Mariner missions flew by Venus and Mars, capturing the first close-up images of other planets. Pioneer 10, launched in 1972, became the first spacecraft to travel beyond the orbit of the outer planets. It sent back valuable data on Jupiter's radiation belts and magnetic field. The Venera program, led by the Soviet Union, successfully landed probes on Venus, with Venera 9 sending back the first images of its harsh surface in 1975. Later, Venera 13 recorded the first sounds from another planet. These missions showed that robotic explorers could withstand extreme conditions and return useful data. In 1977, NASA launched Voyager 1 and Voyager 2 to explore the outer planets. They flew past Jupiter, Saturn, Uranus, and Neptune, capturing stunning images and discovering new moons and rings. Remarkably, both probes are still active, sending data from interstellar space. These robotic missions extended humanity's reach to distances never before imagined. They filled gaps in our knowledge and opened new questions about planetary atmospheres, magnetism, and potential for life. The legacy of these early robotic missions continues to inspire space scientists today. The idea of humans living in space for extended periods became a reality in the 1970s. The United States launched Skylab, its first space station, in 1973. American astronauts lived aboard it for weeks at a time, conducting experiments in microgravity. Around the same time, the Soviet Union was developing its own long-term orbital platforms. In 1986, the Soviets launched Mir, a modular space station that operated for 15 years. Cosmonauts aboard Mir conducted a wide variety of experiments in biology, materials science, and Earth observation. They showed that humans could adapt to life in orbit for months at a time. The success of Mir laid the groundwork for international cooperation in space. In 1998, the launch of the International Space Station marked a new chapter in space habitation. Built by a coalition of nations including the United States, Russia, Japan, Canada, and European partners, the ISS became a permanent laboratory in low Earth orbit. It continues to be a hub of scientific activity, and honestly, it symbolizes what can be achieved when countries work together. These stations proved that space could become a living environment, not just a destination for short visits. Long-duration missions became key to preparing for future interplanetary travel. The launch of Space Shuttle Columbia in 1981 introduced a new age of reusable spacecraft. Unlike earlier rockets, the shuttle could launch into orbit and return to Earth for refurbishment and reuse. This really changed how the world approached space missions. Over the next 3 decades, NASA's shuttle program flew more than 130 missions. One of the most significant uses of the shuttle was to help construct the International Space Station. Astronauts aboard the shuttle delivered modules, conducted spacewalks, and brought supplies to orbit. The shuttle also played a crucial role in deploying and repairing important satellites, including the Hubble Space Telescope. In addition to its technical achievements, the shuttle program helped expand public interest in space. It enabled more frequent crewed missions and demonstrated the value of international collaboration in orbit. However, the program also faced heartbreaking tragedy. In 1986, the Space Shuttle Challenger exploded shortly after liftoff, killing all 7 astronauts on board. A similar catastrophe occurred in 2003 when Columbia disintegrated during re-entry. Both incidents led to major overhauls in NASA's safety protocols and mission planning. Despite its challenges, the shuttle program left a lasting legacy in space transportation and engineering. It proved that spaceflight could become a routine part of human activity, bridging the gap between the early space race and future missions to the moon and beyond. The launch of the Hubble Space Telescope in 1990 gave humanity eyes in the cosmos like never before. Orbiting above Earth's atmosphere, Hubble captured images of galaxies, nebulae, and distant stars with incredible clarity. These images weren't just beautiful, they revealed insights into the age, size, and structure of the universe. Hubble confirmed the existence of dark energy, helped refine the rate of cosmic expansion, and enabled the deepest visible light images ever taken. Its long operational life turned it into one of the most productive scientific instruments ever created. But Hubble wasn't alone for long. NASA and its partners expanded space-based astronomy with other telescopes like the Chandra X-ray Observatory, which studies high-energy phenomena like black holes and supernova. The Spitzer Space Telescope opened new windows into the infrared universe, revealing cool stars, dust clouds, and forming planets. The Kepler Space Telescope, launched in 2009, revolutionized our understanding of planetary systems by discovering thousands of exoplanets orbiting distant stars. Each of these observatories unlocked a different part of the cosmic spectrum, working together to give a fuller picture of the universe. In 2019, the Event Horizon Telescope, a worldwide collaboration of radio observatories, captured the first direct image of a black hole. These achievements demonstrated that even without leaving Earth's orbit, humanity could peer deep into the universe and uncover secrets that had remained hidden for billions of years. The era of space telescopes transformed our perspective from earthbound to universal. Observatories in space are not just tools. They are our cosmic messengers, showing us how vast, strange, and beautiful the universe truly is. The exploration of Mars and the Moon has remained a consistent priority in space science. In the 1970s, NASA's Viking missions were the first to land safely on Mars and transmit data from its surface. Viking 1 and 2 performed experiments searching for signs of life and analyzed Martian soil and weather. In 1997, Mars Pathfinder carried the Sojourner rover, the first mobile robot on another planet. It demonstrated mobility on Martian terrain and delivered valuable engineering and science results. Spirit and Opportunity followed in 2004, significantly extending our knowledge by operating well beyond their planned lifespans. They discovered strong evidence of past water activity, suggesting Mars may once have been habitable. Curiosity joined in 2012, exploring Gale Crater to understand if the area ever supported microbial life. Equipped with a full laboratory, Curiosity has been key in uncovering Mars' climate history. Perseverance, launched in 2020, continues this work and also prepares for sample return missions. On the lunar side, after Apollo missions ended, exploration continued with orbiters like Clementine and the Lunar Reconnaissance Orbiter. Recently, China's Chang'e missions have conducted landings, sample returns, and even deployed a rover. These projects have reinvigorated global interest in the Moon. Robotic exploration of both Mars and the Moon bridges science and technology. It prepares humanity for future crewed missions by testing systems, searching for resources, and identifying potential habitats. These missions help answer whether life existed elsewhere in our solar system and if these worlds might support future human presence. Mars and the Moon are not just targets of curiosity, they are stepping stones for the next great phase of human exploration. The study of asteroids has opened a fascinating chapter in space exploration. In 2003, Japan launched the Hayabusa spacecraft to rendezvous with the asteroid Itokawa. This small probe succeeded in collecting microscopic samples and returning them to Earth in 2010, making it the first successful asteroid sample return mission. This pioneering success proved that even distant and fast-moving targets in space could be explored and studied directly. Following its lead, NASA launched OSIRIS-REx in 2016 to collect samples from the carbon-rich asteroid Bennu. After carefully orbiting and studying the asteroid, the spacecraft successfully collected material from its surface and returned it to Earth in 2023. These samples are now helping scientists understand the composition of early solar system bodies and the building blocks of planets. China has also demonstrated its growing capabilities in this field by performing lunar sample return missions, such as Chang'e 5, which brought back fresh material from the Moon in 2020. The ability to retrieve and analyze extraterrestrial samples in Earth-based laboratories allows for a depth of study not possible with remote instruments alone. These missions are not just scientific triumphs. They lay the groundwork for asteroid mining, planetary defense strategies, and resource utilization in future deep space missions. They expand our understanding of planetary formation and provide a testbed for the technologies needed to explore and even settle beyond Earth. The success of these sample return missions illustrates a major leap in our reach and capability, bridging the gap between robotic exploration and future human involvement with celestial bodies beyond the Moon and Mars. The expansion of space exploration has, increasingly relied on collaboration between nations. In the past few decades, space agencies from Europe, Asia, and beyond have joined forces to pursue missions that no single country could undertake alone. The European Space Agency has partnered with NASA on several major projects, including the Hubble Space Telescope and the James Webb Space Telescope. It also led the Rosetta mission, which, quite impressively, successfully landed a probe on a comet back in 2014. Japan's space agency, JAXA, has contributed to missions like Hayabusa and worked with the United States on the International Space Station. India's ISRO has launched successful missions to the Moon and Mars, while China's CNSA has landed rovers on both the Moon and Mars. These achievements really highlight how space has become a global endeavor. The International Space Station remains the most visible symbol of multinational cooperation, hosting astronauts from over 15 countries. By sharing knowledge, resources, and launch capabilities, these countries amplify each other's strengths. Collaborative missions not only spread costs and risks, but also unite diverse cultures in the common quest to explore the cosmos. This spirit of cooperation is setting the foundation for ambitious future goals, such as returning to the Moon and reaching Mars together. The 21st century marked a shift from government-dominated space programs to, active participation by private companies. Firms like SpaceX, Blue Origin, Virgin Galactic, and Rocket Lab began developing rockets, satellites, and crew transport systems. SpaceX, founded by Elon Musk, revolutionized the industry with its Falcon 9 rocket, achieving the first successful orbital-class rocket landing in 2015. This breakthrough in reusability drastically cut launch costs and paved the way for more frequent missions. Blue Origin, founded by Jeff Bezos, developed the New Shepard rocket, aimed at suborbital tourism. Virgin Galactic focused on space tourism through its air-launched spaceplane, offering civilian passengers a brief experience of weightlessness. In 2020, SpaceX launched the Crew Dragon mission to the International Space Station with NASA astronauts, marking the first time a private company transported humans into orbit. This event was a milestone in commercial space history. These companies continue to advance technologies including satellite mega-constellations, lunar cargo delivery, and interplanetary mission planning. Private spaceflight has fostered a more competitive and innovative industry, attracting investment and talent from across the globe. The private sector now plays a crucial role not only in launch services, but in building infrastructure for deep space exploration. Their rapid development cycles, cost efficiency, and bold ambitions are accelerating humanity's path to the Moon, Mars, and beyond. This new era of space entrepreneurship has opened opportunities that were once exclusive to governments. The rise of private spaceflight is transforming the future of space travel, turning what was once science fiction into tangible progress. The question of whether we are alone in the universe has honestly guided many space missions. Scientists have long suspected that certain places in our solar system could host microbial life. Mars, with its ancient riverbeds and subsurface ice, remains a primary target. Rovers like Curiosity and Perseverance are equipped with tools to detect organic molecules and signs of habitability. Beyond Mars, attention has turned to ocean worlds such as Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. Both are believed to have subsurface oceans beneath icy crusts. NASA's upcoming Europa Clipper mission and proposed Enceladus missions aim to explore these environments for chemical signs of life. Meanwhile, Titan, Saturn's largest moon, has lakes of methane and ethane that pose new questions about what forms life could take. In addition to robotic missions, telescopes like Kepler and the James Webb Space Telescope search distant star systems for exoplanets. Thousands of planets have been discovered in the habitable zone, regions where conditions might support liquid water. Spectroscopic analysis of exoplanet atmospheres may one day reveal biosignatures such as oxygen or methane from distant worlds. The search for extraterrestrial intelligence, or SETI, continues to scan the skies for artificial radio signals from advanced civilizations. Astrobiology, the study of life in the universe, has become a major field of research. The hunt for life is no longer confined to speculation. It is a structured scientific pursuit. Each mission and discovery brings us closer to answering one of humanity's oldest questions. Whether we find microbes on Mars or clues in starlight, the search for life shapes how we view our place in the cosmos. Some moments in space exploration, well, they really do redefine how we see the universe and ourselves. One such moment happened back in 1968 when the Apollo 8 astronauts captured the iconic Earthrise photo. Seeing Earth rising above the lunar horizon made humanity realize its shared fragility and beauty. Then, just a few years later, the blue marble photo from Apollo 17 gave us another stunning perspective of our planet. These images, they fueled the environmental movement and deepened global awareness. In the decades that followed, missions like Voyager 1 and 2 sent back breathtaking images of the outer planets and their moons. Voyager 1's famous pale blue dot image, taken from over 6 billion kilometers away, reminded us of our tiny place in a vast cosmos. The Hubble Space Telescope revealed galaxies billions of light years away, while the Kepler mission discovered thousands of exoplanets. In 2019, humanity saw the unseeable when the Event Horizon Telescope captured the first image of a black hole in galaxy M87. This was a confirmation of Einstein's theories and a demonstration of global collaboration. Discoveries also include evidence of water on Mars and the Moon, and signs of organic molecules on comets and asteroids. Each of these breakthroughs, honestly, has expanded our knowledge and inspired new questions. Technological advances have made space more accessible, but it's those moments of discovery that truly unite humanity. These milestones are not just scientific, they're emotional, philosophical, and cultural landmarks. They change how we view Earth, the universe, and ourselves. As we continue to explore, new discoveries will emerge, each offering another piece of the cosmic puzzle. Space is no longer reserved for professional astronauts. In recent years, private companies have made it possible for civilians to venture beyond Earth's atmosphere. Blue Origin's New Shepard and Virgin Galactic's Spaceship Two have launched suborbital flights with private passengers, offering several minutes of weightlessness. These flights honestly mark a new phase in the democratization of space access. In 2021, SpaceX launched the Inspiration-4 mission, the first all-civilian orbital flight. 4 non-astronauts orbited Earth for 3 days, conducting science experiments and raising funds for charity. This mission proved that spaceflight could be safe, meaningful, and inspirational for ordinary people. Civilian involvement is not just limited to tourism either. Some individuals have joined professional crews on missions to the International Space Station, contributing to research and outreach. The future may see private space stations, hotels in orbit, and even lunar tourism. As safety and cost improve, space tourism is likely to grow from novelty to niche industry. This new chapter in exploration allows more people to experience the wonder of space firsthand. Civilian space travel is expanding the definition of who gets to explore the final frontier. Missions reaching beyond the solar system represent honestly some of humanity's most ambitious undertakings. Voyager 1 and 2, launched way back in 1977, have traveled farther than any human-made objects ever have. Voyager 1 entered interstellar space in 2012 and, believe it or not, still sends back data about cosmic rays and the interstellar medium. These probes carry the golden record, which is a time capsule of Earth's sounds and images, intended for any extraterrestrial life that might find them someday. New Horizons, launched in 2006, flew past Pluto in 2015, giving us our first close-up views of the dwarf planet. It later visited a Kuiper Belt object known as Arakoth, revealing fascinating insights into the early solar system. Future missions propose to travel even farther. Concepts like Breakthrough Starshot aim to send tiny, laser-powered probes to the Alpha Centauri system. These interstellar aspirations are still in the early stages, but they really reflect our desire to reach new frontiers. Deep space probes help us understand the structure of the solar system and the galaxy beyond. They are, without a doubt, a testament to our curiosity and engineering. As we reach farther from home, we continue to push the boundaries of what is possible. Humanity's dreams of space exploration are, honestly, far from over. NASA's Artemis program aims to return astronauts to the Moon and establish a sustainable presence by the end of the decade. It plans to land the first woman and the next man on the lunar surface. This will pave the way for long-term lunar bases, possibly using local resources for construction and life support. Mars is the next big leap. Both NASA and private companies like SpaceX have plans for crewed missions to the Red Planet. These missions involve enormous technical and psychological challenges, but progress is being made in propulsion, habitat design, and radiation protection. Other targets include ocean moons like Europa and Enceladus, which may just maybe harbor life beneath their icy crusts. Space-based manufacturing, solar energy harvesting, and asteroid mining are also being studied as future possibilities. As technology matures, humanity is poised to explore and perhaps inhabit other worlds. The future of space exploration is not just about discovery. It is about survival, innovation, and, well, pushing the limits of imagination. What lies ahead will redefine our species' role in the universe and open doors we once thought forever closed. Just a quick note, disclaimer. As an Amazon and other affiliate, I earn from qualifying purchases at no additional cost to you. Do you like the video and want to make videos like this? Turn text into stunning videos in seconds. Get a free trial and unlock your creative potential. You can create even better videos than mine, honestly. No editor is required. Check out the link in the video description below. Got a favorite mission or a question about what's next for space exploration? Drop your thoughts in the comments. We're excited to hear from fellow explorers. And if there's a topic you want us to explore next, let us know. Your idea could shape our next video. Thank you for joining us on this journey through the history of space exploration. Please like and share the video, and please do not forget to subscribe for more videos.